So today we're going to define limits, and we're going to start graphically because that's probably the easiest way to conceptually understand it. This was at the end of pre-calc, so hopefully this is a review. All right, so limits. As x approaches 2, f of x approaches 1. Right, so here are 3 examples of this being true. So this first one, right, the limit as x approaches 2 of f of x, right? So we're trying to think of, we're always looking to approach 2 from the left and right side. And if that means, right, we're on the graph and we're approaching it from the left, right. So limit is approaching, right? Limit equals approaching. The f of x is the actual value, right? So the limit as it approaches 2 is 1, right? Here it's 1 and here it's 1 because the line is approaching 1. But the actual value is what's different. So here, f of 2 is 1, right? Here, f of 2, since there's a hole, a discontinuity, does not exist, or undefined. In this case, you can use both. And then here, f of x is actually 3, right? So limit is what it's approaching, and then f of x is the actual value. So you want to be able to separate those two. So let's go through some examples. Okay, so it's saying the limit as x approaches 1 of f of x. So if we look here at x equals 1, we can see that from both sides it's approaching -1. Even though it doesn't exist, even though there's a hole, right, limit is just approaching. So we don't care about where it actually is. Now if we look at f of -3, the dot is right here, right? The closed circle is at 0. So this would be 0. So here the limit as x also, like, you could pause and try and do these and then come back and check. Okay, so the limit as x approaches 2, right? Actually, yeah, let me do limits in pink and then this in blue. Okay, so the limit is approaching 2, but the actual value of 2 is 3. The value of 1 does not exist, undefined. The value at -2 is 2, and now we're back to limits, right? So the limit as x approaches 0 is -2. Limit as x approaches -3, they're both approaching -1. So I would get in your head that limit is what it's approaching, and f of something is like what you're used to from like algebra. Okay, give an interpretation of the statement this. So we want to be able to turn this math into English, right? So we're going to say as x approaches 7, f of x approaches 10. Right? And what could this look like? This could look like a few things, right? Let's just say it was a linear function, right? As x approaches 7, so as we're going to 7 on the x-axis, our y value, our f of x, is approaching 10. All right, so let's do some true-false statements. A limit does not tell us the value of f of x, right? So we know that, right? Let's take an example here. The limit is 1, but the value of f of x is 3. So they're not going to always be the same. It just tells us what the function approaches, right? So that's what we've been going on about. So true or false? F of 1 equals the limit as x approaches 1 of f of x in all cases. So this is going to be false. And we can literally point to this example, right? Or we could point to this example. These are both examples where that's not true. True or false? F of 1 is not equal to limit as x approaches 1 f of x in all cases. So this is also false because sometimes it is the same, right? So I'm going to write this. Sometimes where it approaches and the actual value are the same. And then here we'll say sometimes where it approaches and the actual value are different. So if we take a look at when are they the same, we can look at our first example. Right? That one, it approached 1 and it was 1. So that's an example, right? In all cases, this is a very extreme statement. So sometimes it is the same, sometimes it's not. So hopefully this is a bit of a review and you can go through the practice and yeah.